Energy management and efficiency. Energy consumption in facilities varies widely based on the type, the function, the size, and location of the facility. Nevertheless, the following are general patterns and considerations related to energy consumption in various types of facilities. The first is offices and commercial buildings. Now, in offices and commercial buildings, some key considerations include lighting, HVAC, computers and office equipment, elevators and escalators, and others. For lighting, lighting is often the largest energy consuming system, especially in facilities operating during regular business hours. HVAC system is responsible for maintaining ambient temperatures and air quality. Computers and office equipment, they consume a significant amount of power, especially in larger office complexes. Elevators and escalators contribute to energy use in multi-story buildings. Industrial facilities, they include process energy. Manufacturing and processing operations can consume vast amounts of energy. HVAC, temperature and air quality control, can be critical in some manufacturing processes. Lighting is essential, especially in facilities operating around the clock. Motors, they are used in various applications and can consume significant amounts of energy. Retail facilities, lighting is not only for visibility but also for presentation and ambience. Cooling, this involves refrigeration for perishable goods. HVAC for customer comfort. Healthcare facilities. Examples include medical equipment, HVAC, lighting, and others. Now, for medical equipment, these are energy-intensive devices that are used around the clock. HVAC. Now, hospitals need stringent air quality control and may have specialized needs like surgery suites. Lighting. These are 24-hour operations that requires continuous lighting in certain areas. Now, educational institutions. Lighting. Classrooms, dormitories, libraries, and others all need adequate lighting. HVAC to maintain comfort for students and staff. Lab equipment. Often in higher education, research labs consume significant energy. Data centers, servers, they are constantly running, consuming vast amounts of energy, vast amount of electricity. Cooling, servers generate heat, so cooling systems are crucial to maintain equipment performance. Uninterrupted power supplies, UPS, the backup power systems that can be energy intensive. With their backup power systems that can be energy intensive. Hotels. Now, HVAC, guest rooms, common areas, and conference rooms need to be temperature regulated. Water heating for guest showers, laundry, and others. Lighting, both inside rooms and in communal areas. Sports and recreation facilities. Lighting, both for indoor spaces and nighttime outdoor events. Water heating for pools and showers. Refrigeration for ice rinks. Reducing energy consumption. Reducing energy consumption. The following are some ways for reducing energy consumption. The first is energy audits. This involves regular assessment to identify areas of inefficiency. Building management system, BMS. This involves automated systems that can optimize energy consumption based on the facility's needs. LED lighting. This one consumes less energy and lasts longer than traditional bulbs. HVAC system upgrades. Newer, more efficient systems can result in substantial energy savings. Insulation and building envelope. A proper insulation reduces the need for heating and cooling. Renewable energy sources. Solar panels, wind turbines, and others can reduce reliance on traditional energy sources. Renewable energy options for facilities. The move towards renewable energy sources has become a significant focus for many organizations and countries as they seek to reduce greenhouse gas emissions and create a more sustainable future. And the following is an overview of renewable energy options suitable for facilities. The following are some of the energy options that can be assessed. The first is solar photovoltaic panels. Now, they directly convert sunlight into electricity. They are scalable from small rooftops to vast solar farms, decreasing costs. The cons: variable energy production depending on sunlight needs significant space for substantial power generation. Solar thermal systems: they convert sunlight into thermal energy, can be used for space heating or hot water. Cons: they require direct sunlight and may need backup systems for cloudy days. Wind turbines: they are highly efficient in winding locations, potential for significant power generation. They require consistent wind speeds and can be noisy and have visual impacts. Geothermal energy: they use heat from the earth for direct heating or to generate electricity. They are consistent and reliable. The cons is that they are location dependent. High initial investments are required. Biomass and biogas: they convert organic materials like wood, agricultural waste and others into electricity or heat and can be carbon neutral. The cons: they require significant feedstock, potential competition with food resources. Hydroelectric power: they use flowing water to generate electricity, high capacity and consistent. The cons: the environmental impacts on river ecosystems require significant infrastructure. Tidal and wave energy harnesses the energy from ocean waves and tidal flows, predictable patterns. High cost, potential environmental impacts. Battery energy storage systems (BESS), they allow for storing excess energy produced, aids in stabilizing grids and reducing energy costs during peak times. Limited capacity based on battery size, degradation over time. Heat pumps can extract heat from air or ground to provide heating and cooling. High efficiency is one of the pros of heat pumps. Cons: some models have limitations in extreme temperatures. Green building design: they incorporate renewable energy solutions and energy efficiency in the design of the facility, reduces overall energy demand. Cons: might have higher initial costs. Tips for implementation: first, energy audit. Start with a comprehensive energy audit to understand the current energy consumption patterns and identify areas for improvement. Hybrid systems: combining multiple renewable energy sources can provide more consistent energy and improve overall system reliability. Energy efficiency: before implementing renewable energy options, consider upgrading lighting, insulation, HVAC systems and other components to reduce the total energy demand of the facility. Incentives and grants: look for local, state or federal incentives, grants and tax breaks available for implementing renewable energy systems. If you haven't done so yet, kindly subscribe to our YouTube channel by clicking on the subscribe button on the screen. Also, click on the notification button to get notified of our future videos. If you find this video especially helpful, please do not hesitate to like and share with your audience on social media.